All right, we're going to tackle one of the most powerful ideas in all of science. But here's the thing, we're going to make it so simple, you'll feel like you've known it your whole life. By the end of this, you won't have just memorized natural selection, you'll get it. I mean, really, get it.
So let's just start with a simple picture in our heads. Imagine this huge, snowy forest, and into this cold, wild place, we're going to release 100 rabbits. Now these rabbits, they're not all the same. Some of them have these really thick, plush coats. Others have pretty thin fur. And, you guessed it, winter is coming. The temperature starts to drop. Fast forward to spring. A lot of those rabbits, they didn't make it. And that gets us to the big question for this entire explainer. Did some force called nature look down and decide who gets to live? Or did something way, way simpler happen? Let's figure it out. To do that, we have to strip this whole idea down to the basics. So for a minute, let's just forget the word evolution. We're going to focus on 3 incredibly simple rules. This isn't some deep philosophy. It's just mechanics.
So here it is. This is the entire engine right here. Step 1. Individuals in any group are different from each other. That's just variation. Step 2. Those differences can be passed down from parents to their kids. That's heritability. And finally, step 3. The environment, the weather, the predators, the food, it just so happens that some of those differences make it a little easier to survive and have babies. And that's it. That's the whole game.
You notice what's missing, right? There's no plan, no goal, no intention. Natural selection isn't trying to build a super rabbit. It's just a passive process. It's a filter. That's all. Okay, let's go back to our rabbits. Let's apply those 3 rules we just talked about to our snowy forest and just see what happens.
So we start out with a mix of thick-furred and thin-furred rabbits. But after that brutal winter, which ones do you think were more likely to be around in the spring? The ones with the thick fur, right? Of course, they were warmer. And because they survived, they're the ones having baby rabbits. And what kind of fur do you think they passed on? The genes for thick fur. Now just repeat that for winter after winter after winter, and what happens? The whole population starts to look different. It's now mostly thick-furred rabbits.
And this is so important. Not a single rabbit decided to grow a thicker coat. No individual rabbit evolved. The change happened to the group, to the population, over a long time. The mix of traits just shifted. Okay, so that was a thought experiment. Let's look at a famous, real-world case that shows this perfectly. The peppered moths in England during the Industrial Revolution. This is a classic.
So before all the factories, trees were mostly light-colored. And, what do you know, most of the peppered moths were light-colored too. It was perfect camouflage. But then, the Industrial Revolution starts, and it just covers everything in black soot. The trees turn dark, and all of a sudden the entire game flips. The dark moths, which used to be super rare, now had the advantage.
You can see the environmental filter right here. On the light trees, birds could easily see and eat the dark moths, so the environment was filtering out the dark ones. But when the trees turned dark, that filter completely reversed. Now, the birds were eating the light moths they could see against the dark bark. The moths didn't change themselves. The filter of the environment changed.
Okay, let's just bust the biggest myths right now. First, natural selection is not survival of the strongest. It is survival of the best suited for a specific environment. Second, as we just saw, individuals don't evolve during their lifetimes. And finally, there is no goal. It's not aiming for some perfect creature.
And that leads to this really key idea. Being fit is always relative. It's always temporary. The light moths were the winners on light trees. The dark moths were the winners on dark trees. There's no permanent champ. There is only a temporary fit with whatever the environment is right now.
All right, now for the one analogy that's going to lock this whole thing into your brain for good. If you remember anything from this, remember this, the sieve. This is the real aha moment.
Just think of a sieve from your kitchen, the kind you use to separate stuff. It is a completely mechanical tool. It doesn't have a brain, it has no plan, it just separates things based on a physical property, like size. In this analogy, the environment is the sieve. The cold winter, the color of the tree bark, the predators, those are the holes in the sieve. They set the conditions for what gets through. And the population of all those organisms, with all their different traits, thick fur, thin fur, light, dark, that's the mixture of stuff you're pouring into the sieve. All the different variations get poured in together. And here's the absolute core of it. The sieve doesn't choose the little grains of sand. It just lets them fall through. Nature doesn't choose the thick-furred rabbit. The cold winter just filters out the thin-furred ones. It is a mindless, passive, but incredibly powerful process.
See, once you really get this simple idea of a filter, you start seeing it happening everywhere. This isn't just some dusty old idea about dinosaurs. It's happening right now all around us. Ever wonder why doctors tell you to finish your antibiotics? It's because the antibiotic acts as a sieve. It kills all the bacteria that are vulnerable, but if a few have a random resistance, they're the only ones left to reproduce. A whole resistant population comes from that simple filtering. Same thing happens with bugs and pesticides. This one idea explains so much of our world.
And this is the grand result. You take tiny, little differences. You apply that filter of survival over and over and over, and you give it a huge amount of time. We're talking millions of years. What do you get? You get the entire, breathtaking diversity of life on this planet.
So if you had to boil it all down to one sentence, this is it. Nature isn't a grand designer. It's more like a tireless editor. It just keeps what's working for this particular moment and quietly gets rid of what isn't, generation after generation.
But that does leave us with one last really big question, doesn't it? A sieve can only filter the stuff you pour into it, so where did all those variations, the thick fur and the thin fur, the light moths and the dark moths, where did they come from in the first place? Well, to answer that, we have to go deeper, down to the level of genetics. And that, my friends, is the story for our next explainer.